Good day everybody and welcome to the show. So following on from the last episode where we set up our cloned environments, what I'm going to do is set up the basic and classic FreeBSD or LAN network. I'm going to set up basic forwarding, NAT, DHCP, and yeah, we'll see where it goes. We've got no particular script. Now, as is BSD with a beer, I've started off this one with Boddington's, and it's not that this was an offer at my local shop or anything like that. We'll have a quick slurp to begin. Wonderful. And I'll just pour another one in there as we proceed through the episode. Okay, not poured professionally, but it'll do. Right, so to kick off, I am going to put a little tick in my drink lots of beer box, as I now can. Yes, first mission accomplished. Now the other half. So we're going to fire up VirtualBox, and we're going to start our gateway and our client. And wait a moment, I need a faster system. I'm trying to use this as my video series as a precursor to actually buying something like a Threadripper. You know, oh god, what's it called? Is it the 3970X, the 32 core monster? I would really like one of those right now. But anyway, we are in. We've got our gateway on the left and we have our client on the right. I'm going to log in on the gateway first, like so. And there's my keyboard screaming in pain as usual. Now, the first thing to do is there is a sysctl to actually allow forwarding of packets, whether it's NAT based or any other, and I can't remember what it's called, so I'm going to do sysctl a line feed grep forwarding. Is it line feed or pipe, or is it both? Who knows? I am going to enable that like so, and I'm also going to enable it in sysctl.conf because I want it to be applied every time we boot. The alternative way of doing this is to, in rc.conf, you can do something like this, which does the exact same as what I'm doing now, it's just it's in rc and not in sysctl.conf. Now, I did have a run through of this episode and found out after I'd done it that I had somehow managed to record my webcam and my voice, but none of the actual screen, which is, you know, a bit of a problem. So where I've done this, I've basically commented out what I did and I'm going to go over it. So in your sysctl.conf, you won't have this hashed out and nicely written like this. But yes, we want to have net inet IP forwarding equals 1. And once again, that is in /etc/sysctl.conf. And we've already set it manually ourselves with the sysctl command. So all's good. Packet forwarding or gateway ability, or whatever you'd like to call, is now enabled on this box. Now, the next thing is we are going to have to give some IPs to our interfaces. Now, VTnet 0 is the one that actually, well, VTnet 0 and VTnet 1 both have available connections to the internet. So what I'm going to do is I'm going to run DH client on VTnet 0. And I'm now connected to the internet. Easy. Now our LAN addresses are VTnet, the adapters connected to our LAN, or a little private network here, are VTnet 2 and VTnet 3 in theory. Even though VTnet 3 isn't actually marked active at the moment, it's just a placeholder for things to come. So what I am going to do is, I am going to configure our LAN adapter to use 10.31.33.1/24, and that would be the same as doing this if you know the old NetMask stuff, which would be 10.31.33.1 NetMask 255.25.0. They are exactly the same, just one's CIDR, one's NetMask. Use whichever you prefer. And if I look at VTnet 2 now, sure enough, it's got that address. I'm going to quickly log on to our client machine here and log in. And I am going to manually assign it an address within that range. Now this one has only got one network adapter, so VTnet 0, and it's inet 10.3133.2/24. From here I should be able to ping the gateway as I can. So I need to make these static pretty much across both, even though the client is a little bit different to the gateway, because if I go into rc.conf, we're going to do this. Now, as I said, these I already did this because I already done this video once, so I just commented them out rather than removing them. If config underscore VTnet0 is DHCP, which is the same as running DH client on VTnet0. So when we start this system, it's going to use DHCP to get an IP address, which is fine. That's what we want. And the second one, if config VTnet2 inet, yeah, it's pretty much as I just said in the previous 5 minutes. I'm not going to repeat all that. It's going to assign it that IP address, which is what we wanted. So perfect. So I'm now going to save that file. Now, what I'm going to do is I'm going to actually reboot that gateway machine just to prove that it comes up and it assigns its IPs and it gets it dynamically and all the rest. And it also gives me a chance for another quick slurp. Actually quite like Bollington's, it's nice and smooth. Also very weak, but yeah. And I'd say we're back, but we're not. Come on, more speed. So, as you spotted there, VTnet0 and VTnet2 have come up, and if I now log in, I should be online automatically. So that's to Google's name servers. Yep, that's all good. And I should be able to ping the gateway from the client, which I can. So great, we have a gateway that is now talking to the client and the client to the gateway and the gateway to the internet, which is the perfect traditional setup. Now, how to get packets from the client to the internet and back? Well, what we need to do is we need to enable NAT. And for that, we're going to go into pf.conf. So this is my pf.conf. I cannot remember the state this was in at the end of the last video, and as I said, I've already done this one. So yes, we have if x0 vtnet0, that's the one that we're using for DHCP automatically. We've got the second internet connection, which is external 1, which is vtnet1. We've got the first internal network, which is vtnet2, and then we've got vtnet3, which we're not actually using at the moment, but we're going to add it in here anyway, just for ease. On the options, set skip on LO0 basically means whatever you do, don't play around with localhost. It's just easier that way. I mean, PF is default accept anyway, so it doesn't really matter, but yeah, that's what that means. This is the interesting line, or the line that we really care about. NAT on if x0 from int if0 colon network to brackets if x0. What this basically reads as is do network address translation from the internal network and send it out via the external interface. Is the human way. If you're going to ask me why you need brackets around this, I have never found out, but it doesn't work without it. Not a clue. But anyhow, that is what you need, and there are no other rules in here. This is the basic config. Order does matter in PF, so you can't have set skip on LO0 down here in the rules or anything like that. You've got to have tables, macros, options, NAT, and rules. I think there's a few more to that as well, but I'll come to that later in a different video. But that's the basic config. So we've got that, and we're going to check pfctl is enabled. It already is, and we are going to load that rule set. Cool. Now, because of that, if I come across to the client machine, I should be able to root add default 10.31.33.1, which is our gateway box, and I now should be able to ping the internet, which I can. Perfect. Yes, that was Kind of expected chaos, but I suppose I have tried to shoot this video already. And that's the 4th time I've said that. Stop saying that! But yes, anyhow, we now have the basics of a working network, and because of what we did in the previous video, PF is enabled already and PF logs enabled already, so it will automatically load that rule set, and we've automatically got our IPs assigned. So I should just be able to reboot and that will just work. But we want the client to be automatically configured. Now, to do that, on the gateway, we're going to have to install a program called dnsmasq. Now, there are a few different programs that can do this. It's just, I find dnsmasq the easiest, so that's that. I mean, really, I suppose I should be using the internal FreeBSD core ones, but I don't know if there's an actual core DHCP server. Anyway, so once we've got dnsmasq installed, and we installed it with package install dnsmasq, we will go to cd user local etc, and we will edit dnsmasq.conf, like so. And what we are doing is we are going to scan down this file until we find something that starts with interface equals. And this is basically where it's going to listen for things like name server requests, DHCP requests, and all the rest of it. Here we go. This block here. So if you want dnsmasq to listen for DHCP and DNS requests only on the specified interfaces and the loopback, give the name of the interface. So we will. We want it to listen onto VTnet2, which is the LAN address. But we also want to do DHCP, and to do that we need to define a pool, which is basically the range of IPs that can be given to clients. And for that, in the example config, we have to come down to here, where we've got DHCP range equals. Now we want to we're actually going to leave that commented, and we'll put our own. We'll put DHCP range for YTLAN, and we will use DHCP range is equal to 10.31.33.11 to 10.3133.254. And the last argument, the third one, is the least time. When a computer connects via DHCP, it gets told it's valid to use whatever IP I hand you for this amount of time before you have to, renew it or ask if it's okay to continue using it and such. I'm going to say for 24 hours. This is also, it's technically possible that if you're on a busy network, that your DHCP server could say, oh, you need to change IP and disconnect and all the rest of it. But yes, anyhow, that's the least time. You can set that to whatever you like. I think you can use D for days and the rest of it, but for most things, 24 hours, that should be fine. I mean, the default's 12, so yes, we are going to save that change. And we are going to go into rc.conf again, and we are going to add a section for extended network services. And we are going to enable dnsmasq, which is dnsmasq equals yes, like so. And we are now going to start that service. And boom, she's there. Now what this means is I should be able to go to my client machine here and do a DH client VTnet0, and it should get an IP address and everything else, which it did. We're at .59. Little note, you might have seen me set the start of the pool as .10 in the dnsmasq.conf. The reason I did that is I kind of like to leave the first few IP addresses in a range for static services. Obviously the gateway itself is static. Even though it's using DH client to get an external IP address, it is still 10.31.33.1 statically. Most LANs are the same, either the start of the range or the end of the range. Just leave a little bit of room for things that you don't want on DHCP. But yes, anyhow, we've now done that, and we should be able to ping the internet, which we can, and we should be able to actually resolve a domain name. So let's try google.com, which we can. And if I look in my resolve.conf, it's not going to be resolve.conf because it's using Unbound. But does Unbound actually keep its bits and pieces? Okay, I'm not sure. But anyway, because the client is using Unbound, which is what we set up in the first video, well, we didn't really set it up, it's just running. It's basically running its own DNS cache, kind of like Windows does really, and a few other operating systems as well. I think the System D does something as well. Where it's not absolutely reliant on a DHCP server's offering of a name server. We're basically just sending all of our requests to local Unbound and that's it. But when we actually run DH client, it will have actually used the one that it got handed to it by the gateway. In fact, because it's bugging me, I'm gonna have a quick look in here, and I'm sure somewhere in here it should tell us what it's doing. Ah, here we go. So this path is etc unbound forward.conf, and you can see it's generated by resolve.conf. When DH client run, it basically has an anchor that says, okay, you're using Unbound, and it fills in this file instead. So our forward address is 10.3.1.33.1, which is dnsmasq, which is on the gateway, which is perfect. It's just what we wanted. So now what I should be able to do is go into rc.conf, and here we go, network configuration. I want to configure VTNet0 as DHCP. Perfect. So now we have a gateway that has packet forwarding enabled, NAT on the firewall, and dnsmasq. And we have a client that is going to be a DHCP client. So I'm going to reboot the gateway and grab a quick slurp. And wait for it to load. I'm also going to reboot the client machine over here, because this should load up. The only reason I'm rebooting the gateway first is because it takes a little longer to start. I don't really want a race condition, even though it shouldn't matter too much. Now, when this client starts, it should completely be able to connect to the internet with no problems whatsoever and just be all automatic, which is the traditional IPv4 setup. VTNet0 link state up, that's good. I just seen a DHCP flash pie, which is good. So I'm going to log in and I'm going to try and ping google.com, which I obviously have to resolve and ping. And there we go. Hurrah. Huzzah. Said it. No. And that is how you set up the traditional LAN. So from here, we'll be going on to the more advanced stuff, but that is the basics that people ask for. Please subscribe and give me a like if you want to see the continuation of this service. What the hell am I about? This series. Thank you. Have a good night and cheers.